Hello everyone, welcome to Software's classes. This is Tushar Shaw, and in this video we'll be reviewing this book, that is the Organic Spectroscopy by William Kemp. Okay, so this book is like quite a standard book for people who are studying in the undergraduate and postgraduate level, and those who are suffering in the topic of UVIR enema and the spectroscopy part of organic chemistry. Okay, not physical chemistry. For that we have the CN Manuel book, where that I'll be reviewing it later. Okay, so we have this organic spectroscopy. So if you are keen towards studying of spectroscopy, if you are planning to do your PhD in spectroscopy, organic spectroscopy in any of the topics like UVI or NMR, so this book is like a Bible for you. Okay, so it is an extremely good book, and if you are like for a and it is best for the preparation of any kind of competitive non-competitive exams for this part specifically, that is organic spectroscopy. And so let us get to know the details of this book and see what are the salient features, what are the advantages, what are the pros and what are the cons of this book. So we will be going to that all along. Okay, so the name of the writer is William Kemp. Okay, he is. Let me use another pen. So he is a senior lecturer in organic chemistry at the Heriot-Watt University at Edinburgh. Okay, so this is obviously a third edition. The reprints of the obviously this book has a quite extensive patent, so you may not reprint this book, and the PDFs of this book are quite not largely available. So if you require the PDF of the book, I have given my email IDs in one of the earlier videos. You may go check that out and send me an email about this. So I'll be attaching the PDF along with that. Okay, so let us look at firstly the contents of this book. So firstly we have the preface. All the preface, we have the acknowledgements. These are not required for our preparation. So firstly, energy and the electromagnetic spectrum. This is basically a physics part. Okay, the things given here we actually study it in the obviously in school level in physics, because what are the energy units, what are the spectrum units, how do we define those units. Okay, and then there's the electromagnetic spectrum, how there are so many electromagnetic waves, all of them, where what is the frequency of each wave, what is the whole spectrum of that, which wave is used in what purpose, so those kinds of stuff. Okay, now, one con I would like to mention. Firstly, the I guess the most major and the one and only con about this book is for you have given you the supplement of each and every chapter is given after the chapter is explained. So what do you mean by supplement is how we require the energy, how we use this the chapter that is given earlier, how can we use that chapter in a modern time, that is by using of computers and those kinds of stuffs. Okay, why I am is counting it as a con, because they require more time to study and more time to understand, which is basically, and this part won't be coming there in any of your competitive exams. Okay, I am basically a competitive exam oriented person. I would like to I like my students to for competitive exams more, because they tend to cover more of the syllabus than the other non-competitive any other university exams. Okay, so this part, that is the supplement part, after all of the chapter, they won't be coming in any of the competitive exams. Okay, if and only if you are trying to do your PhD in spectroscopy part, specifically in any of the UVI or NMR topics, then this supplement part would be quite beneficial for you. You are basically in your PhD times, you are using this concepts of NMR in your regular day-to-day lab work. So for that purposes, the supplements will be quite helpful for you. But other than that, for students like us, it won't be like any help. Okay, especially for any that you can give it a read obviously, but you would be not understanding this quite properly. And secondly, the knowledge for this of the supplements won't be required in any competitive or non-competitive exams. Okay, so and obviously a further reading is given, so let us skip those part and then move on to the next topic that is given. Firstly, the first spectroscopy that is explained in this book is infrared spectroscopy, which is basically IR. Okay, the vibrational spectroscopy. So firstly we have the units of frequency, wavelength, wave number, those are the most basic thing that we study while studying the spectroscopy part. Then we have molecular vibrations, how vibrations occur, what are the modes of vibration, what are the quantum restrictions that are applied to the vibration so as to not vibrate in all of the set of specific positions. Okay. Then we have this five factors influencing the vibration frequencies. We have all kinds of factors like vibronic coupling. We have hydrogen bonding, electronic effects, bond angles, field strengths. All of these are like related to the how an organic molecule is oriented. What are the shape? What is the shape of the molecule? What are the functional groups of the molecule? And that would like determine what will be the vibrational frequency and the type of vibration looking like. Okay, so that would be one thing. Then we have this instrumentation, that is what are the machines that we use while studying this IR spectroscopy, and how do we operate those machines, and what are the what is the basic dimension of that machines, what is the procedure of how those instruments work. Okay, so firstly we require I'll be explaining it to you like after a few minutes that for infrared, so for IR spectroscopy to occur, we firstly require this infrared sources, that is the and the monochromators. So those kinds of stuff are required. We require detector for the detection of this IR waves. Okay. Then we have this mode of operation, that is optical null and the ratio recording. Then we have this mode of operation called the Fourier transformation in infrared spectroscopy, and this part, that is the Fourier transformation, is most widely used all around the world. Okay, so like we short name it as FTIR. So FTIR process is used all around the world, majorly for any kind of IR related data, because this part is like quite easily used and has a quite large number of applications. Okay, so that is one thing. Then we have to use just using is not the exact way, because we have to calibrate the whole instrument. We have to see whether the instrument properly works or not, and those kinds of stuff. Then we have the absorbance and transmittance scales, because obviously in IR we obtain a graph which has the transmittance on the one side and the wavelength on the side. So we have to calibrate the scales and those stuffs. Okay. So firstly we have the then the sampling techniques, like the compound that we are measuring, the compound that is there in under analysis for the IR spectroscopy. That compound needs to be in the gaseous form, or in the liquid form, or in the solid form, or in the solution form. These has the different instruments would be requiring different type of phases of this the compound that needs to be analyzed. Okay. So FTIR spectroscopy also used in fingerprinting and the identification of functional groups. Okay, so how are they used? So let me just go into that. Firstly, we'll be learning about how the carbon skeleton, skeleton is involved in the FTIR spectroscopy. How aromatic compounds are detected, alkanes, alkyl groups are detected, arenes are detected, and alkynes are detected via the graph that is obtained on the FTIR spectroscopy. Okay. Then we have this carbonyl compounds. We have how can we determine the aldehyde ketones, the esters, the lactones, carboxylic acid, amino acids, and the carboxylic acid anide, right? So and amides and acyl halides. Okay. So the carboxylic acid and its derivatives, the aldehydes and ketones, esters, lactones, and amino acids, all these things are come under the carbonyl compound. And so what would be the kind of graph that will be obtained on the presence of these compounds. Okay. Then we have this hydroxy group because of alcohol, carbohydrates, phenols, ethers. These are the also things. Then we have the nitrogen compounds containing amines, imines, nitro compound, nitriles. The other than that, the halogen and the sulfur and phosphorus compounds. Okay. So these are basically all of the types of functional groups, all the types of varieties of molecules that are given, and according to the type of functional group or the skeleton of the molecule, what will be the kind of data that will be given from the IR spectroscopy. This is quite properly explained in this book. Okay, so I would recommend, highly recommend, as I have said it in the beginning only, that if you are planning to study organic spectroscopy for your any kind of preparation of competitive or non-competitive exams, or for your PhD purposes, this book is a bible for you. You must definitely follow this, and you may keep a reference book as well, but this should be the main book, because everything is perfectly given here. Okay, every concept is properly explained and all of the things. Okay, so moving along, I am not explaining the supplement, because obviously in the supplement you can see that's absorbance, the slit width, the molar absorptivity, and the laser Raman spectroscopy. These are there in the physical spectroscopy part, because obviously we are dealing with the day-to-day machine instrumental activities. So for that you can give it a read, but other than that is not required for organic spectroscopy purpose. Okay. Then we have this the most important part of organic spectroscopy, that is the NMR. Okay. So the firstly we have the NMR, the NMR data that is given majorly in this book. There is firstly the 1H NMR, that is the proton NMR, and the C13 NMR. Okay. So firstly we'll be discussing the proton NMR spectroscopy. So say that is the 1H NMR. So for spinning of the nucleus, the effect of spinning in the magnetic field, what is precessional frequency, and the energy transitions related to that. This is the basic concepts. So you will be learning it quite properly. Okay. Then we have this nuclear theory of magnetic resonance. Then we have this chemical shift, the internal standard, the NMR spectrometer, and the units used in spectroscopy. These are like the most basic things that we require to study before moving into the molecules and studying the details of NMR from the molecules. We have to study the what are the standards taken while calibrating the instrument, what are the, or what does the NMR spectrometer look like, how does it give the values, and what are the units used in spectroscopy. Okay. So those kinds of stuffs. Then we have the factors included. We move into the actual molecule kind of thing. So firstly we are looking at the factors including the chemical influencing chemical shift, that is electronegativity, van der Waals, shielding, and isotopic effects. What is an isotopic effect? I will be explaining later in the video. Okay. Then we have this correlation data for proton NMR, then for restricted rotation. Then we have solvents. Solvents also provide a huge difference in while calculating the NMR data for any certain compound. Okay. So what will be the choice of solvent, and if we shift solvents, what will be the effect on the delta values. Okay. Then we have this integral in proton NMR. Then we have this spin-spin coupling, the spin-spin splitting. How does the coupling occurs in a certain molecule? What is the theory regarding to that? How does we calculate the coupling in terms of coupling constants? Okay. Other complex chemical and magnetic equivalents are given. Then we have the proton exchange reactions. Okay. So those will be those are also the consequences of coupling only. Then we have the factors influencing the coupling constant J. General factors, the factors influencing geminal coupling, vicinal coupling. Those are all of them would be having formulas for that. Okay. Then we have this heteronuclear coupling, the deuterium exchange, those kinds of stuffs. Okay. Then we have the simplification of complex proton NMR. That is, if we increase the field state, how will be the simpler the NMR be simplified? Then we have this lanthanide shared skin reagents. I'll be explaining it to you. Okay. Then we have the C13 NMR. This is obviously not so abundantly given, but it is enough for preparation of GATE and other exams. Okay. So firstly, the natural abundance of C13 NMR, the resolution, multiplicity, those things we need to study. Then we have the deuterium coupling, how the C13 couples with the H2 atom, so giving us some coupling. Okay, we have the quantitative measurement of line intensities. We have the off resonance proton decoupling. Okay, then with the applications of C13 NMR and the correlation data for C13 NMR. Okay. Now, the supplement 3 for this NMR, though all of them are not explaining, the only thing important which you might give a read is the F30, F19 NMR, P31 NMR. Okay, so these parts are like quite interesting, and you might give it a read, as it is there, as we have 1H NMR, C13 NMR. Similarly, F19 NMR and P31 NMR is also like one of the ways of like using the NMR for compounds having fluorine and phosphorus in the system. Okay. This is basically used in inorganic part, because normally fluorine and phosphorus is not a constituent of organic compound, specifically excluding some of the parts. Okay. Then we have this for nitrogen, all these things you can give a read. Other than that, it is not required. Okay. Then we have the ultraviolet spectroscopy. Firstly, what is the chromophore? Okay, the theory of ultraviolet spectroscopy, the orbitals involved. This is a quite important concept. Okay. And we have the Lambert-Beard's law, the instrumentation, what are the instruments used, the Fourier transformation instruments, sample cells, solvents, and vacuum ultraviolet. Okay. So then we have the solvent effect, how solvent determine the lambda max values of the UV and visible spectroscopy. What are the conjugated dynes, trines and polyenes giving the spectroscopy, the spectroscopy related to the conjugated polyenes and enines related to alpha beta unsaturated carbonyl compounds. Then we have the spectroscopy of benzene and its substituents, the aromatic hydrocarbons other than benzene, and then we have the heterocyclic system. So basically, and stereochemical factors including biphenyls and cis trans isomers and the cross conjugation. So basically, all kinds of molecules that are there that exist in organic chemistry, all of them would be showing some delta max values, and how the delta max value is like changed or affected in certain chemical environments. All of them are quite extensively and very properly given in this book. Okay. Then we have this supplement 4, which is not I don't think so it is quite so much important, so we'll be leaving that. Then we have this mass spectroscopy. So mass spectroscopy is also one of the most important things, though it is not taught in the BSc level, it is there in master's level. So you will be like considering this part. If you're if you're giving jam, this part is not required, so you may just leave it if you're doing jam. But other than that, if you're appearing for gate net, this part is required. Okay. So the basic principles of mass spectroscopy is there, how the sample insertion inlet systems take, what are the ion production, how does the ion production take place in the ionic chamber. Okay. The detector recorder system, that is the data handling, all of these are given. Then we have the isotopic abundances, then the molecular ion, what is the molecular ion. Basically molecular ion is the most important ion production produced in the ionization chamber, which give the M by Z value. Okay. So the structure of molecular ion, the recognition among all of the ions, which one is the molecular ion, the molecular formula from the molecular ion, this part is extremely important. Okay. Then we have this metastable ions. So these parts are not so stable, but they can be used in the calculation for M by Z value. So it is given. Okay. Then we have this fragmentation process, about how a molecule can be fragmented into certain types of ions. So that process is also given. So types and rules. What are the rules of fragmentation and the factors influencing fragmentation? Okay. Now the most important part of M by Z, that is the fragmentation associated with functional groups. So any functional group which is there in front of you, how will that functional group be like dissociated, and what will be the what will the M by Z value in regards to that functional group. So for maximum of the functional groups, the exact type of rule, that exact type of fragmentation and the calculation and the data with mechanism is totally given for each and every functional group. Okay. We have alkane, alkene, cyclohexanes, cycloalkene, alkyne, aromatic, hydrogen, alcohol, phenol, ether, carbonyl, aldehyde, ketone, quinone, carboxylic acid, ether, amide. So all of the nitro compounds and sulfur compounds, all of them are quite properly given. I'll be just showing them to you in a bit, so you may see that how important and how informatively this book has provided us with so many information, which is obviously enough for preparation of this part. Okay. So I am not moving into the supplement 5 of this part also. So next we have the best part I like about this book, that it has the overall data is the information is totally given up till the 5 chapters, and then in the 6th chapter we have spectroscopy problems, which is problems related to all in IR, NMR, electronic mass spectroscopy, and the combined UV IR NMR problem. All of them are like quite properly, like many questions are given in regards to all of the chapters. And then not only that, the questions that are given, the solutions of those questions are also discussed in this book. Okay. So what you can do is firstly read all the chapters, then you may solve all the questions, and then you can verify whether the question that you have solved and the answer that you have found out is correct or not. Okay. So this I would consider it as a con. I'm sorry, not a con, a pro. Okay. Pro of this book, that is questions are given, and many questions are given, so that you can practice very properly and quite extensively all the topics that you have already studied in this book, and you can check whether the question that you have solved are correct or not. Okay, so let us get into the text of this book. So I am not reading out the preface because that would be a very absurd thing to do. No one reads the preface in a book. So in the acknowledgements, the introduction of all the chapters are given. So I won't be reading that too. I will just moving on to the spectrum, the data. Okay. So you can see that in the electromagnetic spectrum, firstly the history is given quite a bit. Okay. Then we have the units, how light propagates, what is the kind of what is the wavelength, wave number, frequency. Okay, some calculations regarding to that, examples are given, and then we have the spectra. Okay, so the whole overall spectra of the electromagnetic rays is given with the frequency value and the wavelength values. So it is like quite easy, and the overall diagram for the propagation of light and propagation of electromagnetic waves and the calculations regarding that, all of them are like quite properly given. Okay, then we have this energy in the electromagnetic spectrum, how the spectrometers record the IR, NMR, UV wave spectra. So these are quite properly given. Then the supplement, I'm not going into that. Okay, then we have the IR spectrometer, spectroscopy. So introduction is given, how different bonds give us the different the spectroscopy values. Okay, the stretching frequency values. So this is what you can see, like you can rotate your phone if you are watching this video, so you can see that this is what a IR graph looks like. Okay, this obviously is a IR graph of long chain alkane, which is provided in liquid paraffin nozole and the liquid film. Okay, so this is the CR stretching, CH stretching frequency, this is also CH deficient frequency, and this is the anti-symmetric stretching. Okay, so obviously a long chain alkane is taken. So firstly, we have the units, wavelength, wave number, all these things. We have a number of examples for that. We then have the molecular vibration, most important part, that is Hooke's law. Okay, Hooke's law. This part is quite important. Very like many numericals come from this part, especially both from inorganic and physical and organic IR spectroscopies. Okay. Then we have this some calculations are there. The type of the stretching modes available for CH2 CH2 ion, those kinds of things are there. Okay, then we have this factors influencing vibration frequency, vibrational coupling. We have hydrogen bonding. Also you may give it a good read, it is quite properly given in this book. Okay, then we have this or the example of benzoic acid is given. This would be the spectrum or IR spectrum of benzoic acid be looking like. Okay, here is the C double bond O stretching. Here is the OH stretching, and okay, only this is the overall data. Then we have the electronic effects. Okay, I'm not going into the details of that. If you this book is like available in on the internet, if you don't have this book, you may go and download this. You may go and download that and give a reading. It is quite like a very extremely good book, and for obviously, as I've told it many times, better for a preparation for the spectroscopy part. Okay, then we have the detectors, how the mode of operation, the optical uses, the Fourier transformation, infrared spectroscopy. That is how the mechanism of how this Fourier transformation works. I'm not going into the details of that. Okay, so we'll be getting from the Fourier transformation, we'll be getting this kinds of graphs as I've already seen. So and then the calibration for the frequency scale, the absorbance and the transmittance scales. Okay. Then we have sampling techniques. So I'm not going into details of that. We have liquid, solids, we have solid films, we have solutions. Okay. And we have the application for functional groups. So you can see that many charts are given, carbon skeleton, aromatics, all of these things are there. So for where on a graph, where would be the plot for which of the following function of which of the functional groups. So that kind of all of these are properly explained. It is I like highly prefer this book for that for this part. Okay. Then we have this alkenes. I'm not going into the details. So questions are given obviously. So this is the supplement part obviously, so we won't be looking into that. Then we have the NMR part. We have this proton NMR, then the how NMR works, the precision, frequency, the energy, the theory about the NMR. We have the chemical shift, the measurement, the standards. Okay, normally the standard taken is TMS, trimethylsilane. Okay, then we have how the instrument works, the spectrometer, then the values about how delta value works, okay, in reference to the TMS. Many examples are there. And then we have the exact thing, that is the factors influencing chemical shift, electronegativity, those kinds of stuffs. Okay, so in that way we may find out the exact delta value for each of the hydrogens in the some specific carbon compound that is given. In this case you can see that in cyclohexane the delta value for this hydrogen is asked, and they have calculated accordingly. Okay, so the solvents used are these kinds of solvents that are used. Okay, then we have this integrated proton NMR. I'm not going into the details. Factors influencing the coupling constant. Okay, let us move it down. Here we have this carbon NMR. Sorry, no, proton NMR is not finished yet. Okay, then we have the C13 NMR. Okay, so C13 NMR is like, obviously as I explained, it is like not so extensively explained, but the amount of information given in this book is quite enough for net and gate. Okay, so I'm not going into details of that because you have seen already that NMR is very properly, very in a best way it is explained in this book. Okay, so yeah, moving on to the next part, that is we have this. So NMR part is not finished. Okay, so here we have this UV visible spectroscopy. Okay, so the color and light absorption, the chromophore, about how the wavelengths of certain functional groups. Okay, then this diagram is, as I explained you in the contents, this diagram is extremely important. Okay, because the electronic transitions for C is single bond C, double bond C, say double bond O, and say the conjugated double bond. Okay, so that was one thing. Then we have the instrumentation, sampling. Okay, we have the choice of solvents. Then we have the solvent effects. Okay, then we have this Woodward rule. Okay, so Woodward rule is obviously required for calculation of the lambda max values for any compound that is given. Okay, then we have this application and of electronic spectroscopy in heterocyclic systems. Then we have all kinds of systems are given. Then we have the supplement. I'm not going into that. Then we have the last part of the book, that is the mass spectroscopy. So basic principles are given. The instrumentation is given. How the instrumentation quite properly explained in this book. Okay, the formulas are derived. Okay, then we have this isotope abundances, the molecular ion, how can we represent the molecular ion, so what will be the mechanism of the formation of molecular ion. Okay, so those information is given. So yeah, so and the isotopes of reduction by in mass spectroscopy. So all these things, like in mass spectroscopy, no, it is not nothing is there to so explain so much. Okay, then so the last part of this book would be you can see the spectroscopy problems. So infrared problems are given, infrared graphs are given, and some many problems are given related to that. Then we have the NMR problems. Many graphs are given, and according to that the problems are there. Okay, the spectroscopy, electronic spectroscopy, UV problems are given, mass spectroscopy problems are given, and conjoint UV-IR visible mass spectroscopy problems are also there. Okay, like this would give you a huge practice about all the types of spectroscopy which you have studied already, and would be like giving an exact representation about how you have studied and whether you will be able to solve these questions in a competitive exam or not. Okay, so let us end this video here. I guess the book is completed. Then we have this appendixes index. Okay, so yeah, so this was all about this book. I hope you have taken some good lessons from this video about how to study this book and what are the like in what way you can follow, so that you can take in the material to overall and like prepare quite extensively for any kind of exam that you're preparing for. Okay, so thank you guys for this video. I'll see you guys in the next one.